Have you ever seen a village without electricity? Have you ever seen a city, a major city, during a blackout? As soon as they would get electricity, they could dig much deeper wells, bring water up, and that would transform everything. Access to electricity meant a jump in the quality of life and economic well-being of the society. I worked on electrification and how to make our electric networks and infrastructure, critical infrastructure, smarter, more resilient, and more efficient. When we look globally on the entire picture of the Earth at night, you will see the networks of electrification. On top of these networks, we develop everything else. One of them is our economies. What would you expect the GDP, the wealth of nations, the propagation of wealth, where do you think those are centered around? They're centered exactly in areas that are affordable, available, and high degree of electrification. To look at this from a broader picture, as we project forward, we currently have 19 cities with 10 million or more people in them. By 2020, there are going to be 30 such cities. By 2050, 60 such megacities. Currently, there are 1.2 billion people in the world that have no access to electricity. Another 1.4 billion have inadequate access. They have outages of 4 hours or longer per day. In order to bring electricity to still assuming 40% of the population of the world has diminished access to electricity, we still need to triple the amount of generation. So when you think ahead tonight, this evening, one of the key things I want you to consider is the impact, the footprint that we develop using our energy resources and how we approach that. In particular, I want to leave you with one of the nuggets is when you look at electrification and you look at how we have harvested our energy resources, hunter-gatherers used about 2,500 calories per day. The agrarian society, about 10,000 calories per day per person. Currently, us in the more developed parts of the world use anywhere from 50,000 calories a day. Everything we use, iPhones, iPods, computers, transportation, up to over 600,000 calories per day. However, our approach to our energy resources are very similar to hunter-gatherers. We drill a hole, exhaust the resources of that hole, move on to the next, move on to the next, move on to the next. So we need to evolve to a higher level of energy harvesting and energy utilization. In addition, if we step back and we think about environmental security, economic security, and national security, at the nexus of all three is energy security. There are no silver bullets, but there are many innovation bullets, and I'm going to share some of them with you. In particular, it is noteworthy that in 2000, a blue ribbon panel at the National Academy of Engineering ranked the top 20 greatest achievements of the 20th century. You would have expected television, rapid transportation, internet, or man going to the moon to be, especially because Neil Armstrong was the chair of this Blue Ribbon Commission. But what do you think they selected? Networks of electrification. Without the grid, we could have not done any of the above. And we always take it for granted. And it's the whole system of generation to the end use, to the delivery. The middle part is the transmission and distribution. This amazing system, this marvel of engineering, is under a lot of stress. The outages cost our economy in the United States somewhere between $80 billion a year to $187 billion a year. In an average year, it cost us about $150 billion a year in spoilage, lost productivity, and other economic impacts. When we look ahead for the next 10, 20, 30 years, what we currently have in North America is 450,000 miles of 100,000 volts and higher, what we call 100 kV or higher, which is the backbone. As we look ahead and we think about where the resources are for energy security, for environmental security, for economic security, To meet the three objectives, we are going to need a stronger and smarter grid. What do I mean by stronger grid? The 450,000 miles of high voltage lines need to be strengthened by adding another 9%, about 42,000 miles, to bring electrons from homegrown sources such as wind, solar, geothermal, biomass, what you're seeing behind me on the map. This assessment has been done by the Department of Energy, by my former organization, the Electric Power Research Institute. This would enable integration of about 40% of energy coming from wind, and introduces the most efficient carrier of energy, by the way. What do you think it is? Is it hydrogen? Is it biofuels? Is it liquid fuels? Or are they electrons? The most efficient carrier of energy. Electrons are the most efficient carrier of energy. That's why we need this electrification, to bring it from where the sources are to where the demands are. And the high voltage transmission, by the way, is 97% efficient. 97% efficiency, so Tesla's original dream was correct. So how do you make it smarter? What's the overlay of sensors, communication, ways to make the system more resilient and smarter? How much do you think, how many of you tweet? How much does your tweet use? Not just our device, but the whole system. The whole system. The communication, the mobile platforms that we have, the wireless system, the server farms, and so on. The whole system uses 0.025 watt hours. In 2011, we averaged about 1 billion tweets per week. You multiply them, it's 2.5 large nuclear power plants just to keep our tweeting habit going. And this year, we are up to 1.7 billion tweets per week. So it has increased. So as you look ahead, there are many opportunities. And electricity, it improving quality of life, innovations in electricity created a toolmaker's dream. The precision, the applications we use it for in our manufacturing, in our room right now, and in everything we use is amazing precision. And there are many innovations coming out of it, such as smarter systems, devices that we have built to power progress, to power our nation's economy. When you look at what else is possible, I want to ask you a question. This suite of technologies, what other benefits, what other improvements, as you drive home tonight, during the reception, before you drive home, what new things can we bring by this suite of technologies, the overlay of devices that enable a more resilient, smarter, more secure, more reliable system? Thank you.